Hello students, welcome back. So in this session, I'm going to be talking about Pandas series. There are two types of main objects in Pandas. There's a series and there's a data frame. So these are the two main ones that we work. Mainly, data frame is the major one. Series, occasionally you may have to work with series. So what exactly are series? They are one-dimensional data. A data frame, on the other hand, is two-dimensional. Think of series as a column of your table. Okay, the whole values inside your column, that will be your series. A data frame, on the other hand, consists of your table, the whole table, like rows and columns all mixed together. That's your data frame. All right, so let's work with some series today. So I import my pandas as PD. Okay, and I'm printing my panda version. In this case, it's printing 2.2.0. Okay, then I'm importing my warnings and I'm ignoring all my warnings. All right, now let's create a series. In this case, I create a series. I use my list. List is, let's say this is a list of age. Okay, so these are people's age. And I create a series from that. And I say S equal to PD.series L. S has to be capital. Mind you, S is capital. Series L. L is my list right here. You pass this L parameter into the series and it's going to create a series. And I run this and it prints out my series. First I print my series and I also print the type, what type it is. And as you can see, it prints out pandas core series.series. And I print my S and this is my series right here. Okay, it prints out 90, 30, 40, 20, 80, 10. These numbers 0, 1, 2, 3, 4, 5, these are your indexes. So these are called indexes and this is the value for the series. All right. Sometimes you may have to access a certain element of a series. So the logic is similar, just like how we did in the list tuple, how we did in the string, same concept applies over here. So let's say I have a list. Okay, this is my list, L equal to this, list of age, same thing, and define my series, S equal to PD.series of L, and then I print my S. And let me just do this one at a time. Comment this thing out, run this, and it prints out my S. Okay, I print my series out. Then I want to access the element at index 3. Now remember, your series, just like in your list and tuple and your string, your indexing always starts with 0. So if I want to print my element at index 3, this is going to be this one at index 3, 0, 1, 2, 3. And if I run this, it's going to print 20. And as you can see, it printed 20 over there. By the way, this D type int64 is refers to. This means that this particular value is being treated as an integer. If I type S square bracket 1:4, that means print elements from index 1 all the way up to index 3. But it's not going to print 4. Okay, the index 4 is not get printed. It actually stops there. So it's going to print from index 1 to index 3. Index 4 where it stops. So as you can see, it prints out 1, index 1, element at index 2, and element at index 3. But it does not print the element at index 4. If you want to print the first 3 elements, so you want to say 0:3. So it's going to print element at 0, 1, and 2. Likewise, if you want to print elements from index 2 all the way up to the last element, you're going to type S2 colon. And as you can see, it starts with 2 and goes all the way up to the end. So it starts with index 2, which is my 40, right? This is my index 2 and goes all the way up to end right there. Oops, let me just highlight this. This is exactly same as this right here. Okay, so the concepts are same as these indexing and slicing. Those concepts are similar to the ones that we discussed in list, tuples, and strings. Operation on series. So let's do a few arithmetic operations on series. Now, this is my series. Let's say you want to add 5 to every element. You can do that too in series. So this is my series. I want to add 5 to each one of the elements. All I have to do is just type S plus 5 and it's going to add 5 to every single element. You see that 25, 15, 45, 25. All these elements 5 has been added. What if I want to multiply every element by 2? I can do that too. I can say S times 2. That's going to multiply every single element by 2. You run this, you can see every single element has been multiplied by 2. Likewise, if you want to divide every element by 10, you can do that too. Divide each element by 10 and it does it for you. You see, 30 divided by 10 is 3, 20 divided by 10 is 2, and so on and so forth. So you can see all the values are there. And then, of course, you have Boolean filtering. So, Boolean filtering, let's say you have a series like this and you want to filter all the elements that are greater than 25. So the way you do, you create a mask first. This is called mask. You create a mask, and in the mask you specify your filter condition, that you want to filter elements that are greater than 25. So S is greater than 25. And then you print S square bracket and you print your mask. Now if you run this, it's going to print all the elements that are greater than 25 right there. Okay, only these elements are greater than 25. This is a simple example of Boolean filtering. Let's look at some of the methods of series. Let's look at some of the statistical methods. And let me create a few cells. So let's say I have my series right here. 30, 20, 10, 40, 20, 30, 20. Okay, I convert into series. This is my list. I convert it into series. And now I want to see the mean value of my series. If I run this, it's going to give me my mean value is 24.28. So it calculates the mean for you automatically. All right. What if I want to calculate the median value of that? There's a function called, there's a method called median. That's going to calculate the median of your series. If you remember, the median is, the way you find your median, you arrange these numbers in smaller to higher number in an increasing order. And then you find the middle number. The middle number is your median. All right. What if you want to find the standard deviation? You can also find standard deviation of your series, s.std. Okay, standard deviation. What if you want to find the maximum value of a series? You can find that too. In this case, maximum value is 40. You can see the maximum value over here is 40 right there. What if you want to find the minimum? Well, there's a s dot minimum. And likewise, if you want to calculate the sum of all, you can also do the sum of all. And there you go. The minimum is 20 and it sums the answer is 170. If you add all these numbers, okay, the answer is going to be 170. Okay. Now, sometimes you have to do cumulative sum and cumulative product. Cumulative sum and cumulative product. So let me comment this out. Let me print my first S so you see what S is. This is my S right there. Now I want to print cumulative sum. Cumulative sum means that it's going to take first element 30. This is your 30. Then it's going to take 30 plus 20. The answer is 50. It prints 50. Then the next element is going to be 30 plus 20 plus 10. Okay, 30 plus 20 plus 10. And the answer is 60. It prints out 60. Then you take 30 plus 20 plus 10 plus 40 plus 20. And the answer is 100. And it keeps going like this. So this is called cumulative sum. Very helpful. Sometimes in mathematical operation, you need a cumulative sum of a number. Likewise, sometimes you need cumulative product. There's a cumulative product too. S dot cum product. And that's going to give you cumulative product. Cumulative product, similar concept. Okay, same concept as a cumulative sum, except now you're multiplying numbers. So the first number is going to be 30 because that's your 30. Prints out 30. The next number is going to be 30 times 20. Okay, 30 times 20. So let me show you what's happening. So maybe you'll have a better idea. All right. So the first number is, my numbers basically are 30, 20, 10, right? 30, 20, 10, and then 40, and so on and so forth. So my first number is going to be 30. 30, okay, printed 30. My next number is going to be 30 times 20. 30 times 20, all right? The answer is 600. So it prints 600 right here. My next number is going to be 30 times 20 times 10. Okay, so it starts 30, 30 times 20, 30 times 20 times 10, 30 times 20 times 10. And the answer is 6,000. Okay, this is how you come 6,000. The next number is going to be 30 times 20 times 20, sorry, times 10 times 40. 30 times 20 times 10 times 40. And the answer is 2, 4, 1, 2, 3, 4, and so on and so forth. Okay, and this is how they come with 24,000, 240,000. Okay, then you can also look some more statistics. So same list, same series. Let's print my series again. So you can see I print my S. It's basically same series, 30, 20, 10, 40, 20, 30, 20. Okay, I want to see all the stats. I want to see the minimum, maximum, and the way you can see all that is by using s.describe. If I run this, it's going to give me stats for this value, the descriptive statistics of this. So the count is telling me 7, that there are 7 elements. Okay, you can count 1, 2, 3, 4, 5, 6, 7 elements. Mean value is 24.28. So the mean value of this right here, okay, is 24.28. So oops, let me come over here. All right, so the mean value of this data, okay, mean value of this data is 24.28. Likewise, standard deviation is my, for this value, okay, this is my standard deviation. Then you have minimum value. The minimum value is 10. You can tell this is my minimum value right here. All right, then it tells me that my 25 percentile, okay, 25 percentile, remember this is percentile, not percentage, percentile. Okay, so that means my 25th percentile is 20. In other words, one way of saying this thing is 25% of my data falls below 20. That's what it means. All right, then your 50th percentile is 20, same thing, and your 75 percentile is 30. All right, and your maximum value is 40. Okay, your maximum value is 40 right there. All right, you can also calculate different percentile. So let's say I want to calculate 25th percentile. I can run this and that's going to give me 25th percentile. I can calculate just one strategy. I can calculate 35th percentile, 75 percentile, so on and so forth from here. I can also calculate standard error mean. So standard error means in this case is 3.688. I want to calculate how many unique elements are there. Okay, it tells me 4 unique elements. You see that 30, 20, 10, 40. Yep, 30, 20, 10, 40. These are the only unique elements. These 2 elements, these 3 elements are getting repeated. I want to count. I want to show me all the unique elements. So s.unique, and when you run this, it's going to show me all the unique elements. 30, 20, 10, 40. 4 elements are unique. It gave me 4, and these are my 4 elements. So I can find those elements. Maybe I want to know the value count. I want to tell me, give me the frequency of every element, like each element, how many times is being repeated. So it's telling me 20 is being repeated 3 times, and you can tell 20 is repeated 3 times. You see 20, 20, and 20. Okay, 30 is being repeated twice, and you can see 30 is over there and 30 is over here. You see it's getting repeated twice. And then 10 is getting repeated only once, and 40 is getting repeated once. So this is called value count. Very useful. Maybe I want to know what is my index of the minimum value. So index of the minimum value. In this case, it's going to give you the index of the first minimum value. So it's giving me index as 2. So if you come over here, you see that you're 2 right there. Okay, and the minimum value is 10. So it gave me the index of the minimum value. It did not give me the minimum value, it gave me the index of the minimum value. Likewise, I want the index of the maximum value. I run this, it's going to give me the index of the maximum value, which is 3. And you can see that element at index 3 right there is 40. And 40 is your maximum. Very useful tool. Occasionally, you may not have to need the value, you want the index. And this is one way you can find the index. Let's look at some few string operations. Let's say you have a series like this: Ash, Kumar, Bob, Shamlodia, Tanner. You want to convert everything into an uppercase. You can convert everything into uppercase by using s.str.upper. If you run this, it's going to print everything into uppercase. As you can see, everything is uppercase. If you want to print everything into lowercase, you can do that too. s.str.lower. And as you can see, everything is being printed into lowercase. All right. If you want to know what the size of length of each string, you want to know what is the length of each string, it gives you that too. So it tells you the length of this string is 3. You see, 3 characters. The length of the next string is 5 characters. The length of the next element at index 2 is 3 Shimlodia is 11, and so on and so forth. Okay. Handling missing data. A lot of times you may actually have to work with handling missing data. So let's say you have a series 1, 2, none, 4, none, 1. So these values are basically, none means there's nothing over there. A lot of time when you read your data, there may be nothing in there. So you want to check for null. So the one way you can check for null is there's a is null function. If I run this, it's going to tell me whether it is true or false. So it's going to tell me false, meaning there is this value is present. Okay, so is null is false. Is null is false. You're looking for true. You see that? True. So these values are missing. Element at index 2 and element at index 4. And you can see element at index 2 right there is missing, and element at index 4 is missing, none. Now you can also fill. Replace NaN with 0. Maybe you want to fill these values. You realize that there should not be none, there should be 0. You can do that too. And as you can see, now your values are 1, 2, and you see this value was missing. Now it is 0 over there. This value was missing. Now it contains 0. You can put whatever value you want. You can put something else. You can also drop a none value. So let's say you want to drop a value. You can do that too. So in this case, it's going to drop the element at index 2. You see it's gone. And as you can see, the element at index 2 is gone, and also element at index 4. Remember the index 4, this was none. So this was none and this was none. So those two values are gone. So you see 0, 1, 3, 5. Element at index 2 and element at index 4 is gone, because the element at index 2 was null and element at index 4 was null. You can also sort the series. Let's say this is your series and you want to sort them in ascending order. So you can do s.sort underscore values, and it's going to sort that. And there you go, 2, 10, 20, 30, 90. It sorted it. All right, so this is a small, simple introduction to series. Thank you.